friction lab, draw free body diagram of the shoe, derive the equation, coefficient of static friction equals tangent theta. Here's our angle theta, and here's our system of coordinate x and y. Please understand that the angle theta is the maximum angle where shoe still holds itself on the incline. It just begins to slide. That's why we can still say that the shoe is in equilibrium, but it experiences the maximum static friction during that moment. This is my free body diagram of the shoe. I represent the shoe as a dot. I put the mg force downwards. Normal force is perpendicular to this inclined plane, which is along the y-axis, and the force of static friction is parallel to the x-axis, parallel to the inclined plane. Those are the only three forces acting on the shoe. Therefore, these are the only three forces I'm showing on the free body diagram. I'm not showing the components. I'm not showing the inclined plane. I'm not showing x and y direction. This is the only thing that should be shown on your free body diagram. Dot the vectors of forces and labels for each of the force. So for x direction, the second Newton's law would look like this: the sum of all the forces equal to 0, because there is no acceleration in x direction. It's still an equilibrium state, which means that the component of the mg in x direction, which is mg sine theta, is going to be equal to the force of friction, of static friction, in the opposite direction. So those two forces will be balanced because acceleration is 0. That's what's happening in x direction. So in y direction, I have equilibrium as well. My acceleration is 0. Therefore, the second Newton's law in y direction will look like this. The normal force, which is positive, right? My positive y is upwards, equals the component of the mg force in y direction, which is mg cosine theta. So if you have questions why it is mg cosine theta and why it is mg sine theta, please let me know and I can make a separate video on that. But here's your second equation. You need to have a third equation that connects the force of static friction with the normal force. And that is the equation from your reference table. So here's this equation. The maximum force of static friction on the left equals coefficient of static friction multiplied by the normal force. Now you can use the three equations to solve for coefficient of static friction. So after you do some algebra with these three equations, you get that coefficient of static friction equals sine of theta divided by cosine theta, and using trig relationships, you'll get that it equals to tangent theta. So that was the video explaining the derivation of this equation and the free body diagram. Thanks for watching.